We discussed a little bit, well, what are the pros and the cons, and certainly, for engines of those sizes, I mean, for huge container ships, they don't want to lose their warranty on the engine.
Mhm.
We need to have some information on what does this technology, what do the plasmoids do to the engine parts, the
Okay,
internal
so
parts?
can I just I'll attack that question right now.
Hmm.
Um, if you go and look at the research that I did in 2019 with Amasa gas, particularly the videos with the testing, um, I think it's called the end of the beginning or the beginning of the end or something like that. The long uncut video, and in concert with the other ones. When you have raw HHO and it is burnt, and HHO, if you look at the work surrounding that, it has some atomic hydrogen in there, and it has these buckyball-like clusters of water molecules. This was, I think, predicted by MIT, but Roish and Amasa actually built a special mass spectrometer system, and it cost them about $1 million at the time. And there's a little video clip where on a news program, if you go and look at Roish and Mars's websites, where you can see, and I've grabbed that in various presentations, but anyway, they show these molecular buckyball different structures, and they're literally like these geodesic structures, and you can imagine that the water is clustering in that form.
Which clusters were that?
Well, it's in the water gas.
Hmm.
Now, this is kind of sort of what Malcolm is thinking in terms of these structures, which all have either the negative parts of the polar molecule pointing outwards or the positive parts. If you imagine you're producing all one kind of that, then those little particles would repel each other because they're all presenting either positive or negative on the outside. Yeah. And so it would represent as a gas, but it's actually geodesic structures of water molecules. And the thinking is that the atomic hydrogen is trapped in there because they observe in this gas the actual atomic hydrogen, which shouldn't be in there long after it's produced. And also, Mars gas was able to be stored in a pressure container, a steel tank, for 10 years without any hydrogen embrittlement. And
Hmm.
for that to be the case, the hydrogen mustn't be in an active state, but it's still in there. Now, that is the understanding that they have. I believe that the cavitation in concert with the electrolysis um, produces a particular form of matter, which the Russians call magneto-toro electrical clusters, which are the same as exotic vacuum objects, which are the same as the abbreviated term plasmoids, which is an abbreviation from plasma toroids. And these are fractal electrodynamic structures. Now, in the Russian work, they say that in ordinary matter, there are three components. There is the electron, the nuclei, and this cluster of what must be, because it can affect inverse beta decay, background relic neutrinos in a condensed toroidal cluster form. And when you produce these things, they're neutral, but they can be partially charged, but they are slightly magnetic and they get bound to oxygen because of the paramagnetic nature of oxygen. And so by separating the water electrically and with cavitation, in this case, you produce this material that is like highly energized oxygen dissolved in water that has these bound clusters to them. Then, when you burn it, and in the case of a Mars gas, you're burning it directly. In the case of the thunderstorm generator, you are burning it inside the chamber, and you're initiating the burn with the spark plug. You release these clusters, and according to Shishkin, Kurols, and Dubovik, Dubovik is the discoverer in 1965 of the toroidal moment. when you blow up these clusters, they produce up to 10 to the 11 electrons. So you are gaining from the initial electron a vast number of electrons, and the electrons themselves produce, in the turbulence of the combustion chamber, a vast number of plasma toroids, because the turbulence leads to vorticity, the vorticity leads to self-organization, leads to the plasmoids, and the plasmoids are little micro machines that are able to focus matter, get them to react, and if they're large enough clustered, it would appear that they produce at the phase singularity a topological monopole, which can lead to mass condensation at a level that's so high it exceeds the Schwarzschild limit, and you get effectively a black hole. And so the matter can go in there, be reorganized, and it gets reborn. Okay, and this is all effectively in line with the work of Takaaki Matsumoto. So if you look at his book on page 90, he shows what his 10 year or 11 years of work is. He says that basically there is a point of electronuclear collapse here, and that would be the topological monopole. And then it becomes unstable and blows up, and you get a wormhole of stuff coming out, and then you get generation of titanium and iron. These are both things that we saw in the generator. And also you get generation of hydrogen, carbon, and oxygen on the outside. So you get rebirth of material, okay? But the reaction dynamics are such that if you don't have carbon in play, it behaves completely differently. So if you look at our study, I took a bolometer because there's all this story about, you know, HHO, Brown's gas, produces such high temperatures that in the case of tungsten, it will vaporize it. So that's the story I was told, but I didn't want to believe what anyone else was saying. I thought, I'm going to see for myself. I've got this unique opportunity to go and experience the supposedly the best HHO gas that's ever been produced, and I want to take a series of experiments. So I saw his party tricks. This is Dr. Roy Shinamasa's ones, which was put it on to a titanium 2 mil plate or 3 mil plate, and it immediately punches a hole through. Okay. Mm-hmm. Same on tungsten. But if you go and look at that with the bolometer, in both cases, I don't think it's even exceeding 800 degrees. And tungsten shouldn't even be oxidizing at that temperature. And titanium and tungsten shouldn't be vaporizing or having holes punched through them. Just impossible, right? The gas itself, from the measurement that I was looking at, was about 130, 140 degrees. That is in tune with other people's experience of the temperature of the gas itself. Now, the interesting thing is, I then took a piece of indium foil, the thickness of a human hair, 75 microns, because I wanted a particular type of metal that did not burn on its own in air, but had the lowest possible melting point, right? And I took this ridiculously hair-thin shim, which is actually used as a heat sink in the control electronics for a laser. Okay, that's what it's for. And we took the same gas that we had just seen vaporizing tungsten and applied it to this indium foil. And you know what it did? It glowed as brightly as a tungsten filament light bulb, which is ridiculous because it should melt at 156.6 degrees centigrade. And under the high-speed camera, it turned to jelly. It didn't even extend under gravity, even though it was the thickness of a human hair, and it's the same gas we were just vaporizing tungsten with. Okay. Mm-hmm. Then a few seconds later, you see on the video these jets coming out. Under analysis on the indium, after the jets came out, it then gets thermally hot, and everything is explained, right? What is happening is ball lightning, effectively clusters, plasmoids are forming in the metal because it's cohering this extra charge that's coming out of the Amasa gas, which I described how that comes about to the best of my understanding earlier in this conversation. It is then causing this matter collapse. Carbon is being born, and the carbon is very special, and I'll come on to that, but essentially what that does is it starts thermalizing. How do we know that? We know that because if you add 10% of propane to Amasa gas, you cannot punch a hole through tungsten or through titanium, the same titanium sheet you just punched a hole through. And you can't disintegrate the tungsten. Okay, so titanium, it doesn't punch a hole through, but the temperatures on the bolometer are far hotter, and it glows hotter. The metal glows hotter, like hot, rather than white. Now, my understanding is when you have a ball lightning, the electrodynamics inside create a different permittivity of the vacuum. And you can go and look at Ken Shoulder's paper, Permittivity Transitions, which goes to a large extent to explain this in an exotic vacuum object, which is ball lightning, which is a plasmatoroid abbreviated to plasmoids, right? And in there, because the space and time is different, the speed of light is different and time is different. When light goes into it, and that can even be thermal photons, it gets blue shifted, and because the photons themselves are how should we put this? They basically, because they're blue shifted, the frequency goes up, and so you get light that is very bright to the eyes, but is not thermal. It's not thermal. So it's incredibly bright because what you get this incredibly bright UV light coming out. It ionizes air around, and then you get the other spectrum of light coming from the air. So it's not heat that's melting it. But if you add carbon, and I can't remember where I read it, but the carbon is 32 times more good at thermalizing this. And so when the neutral radiation, which normally would cause, and so another experiment I did, which had never been done, because I didn't believe what anyone else had said, was when we did the experiment with the tungsten under my plan. I got a world's ball lightning expert, Dr. George Eagley, and I said, can you get a vacuum cleaner and put a face mask? And of course, this was 2019, before they were fashionable. I said, put it over the end, and I want to suck some of those particles that are coming off the top, this so-called vaporized tungsten. And on the actual tungsten itself, we have a magneto-hydrodynamic structure forming, where at the lower part, where the torsion beam, this normal relic neutrino flux is pulled in so much so that it overexcites the atoms and causes them to start to disintegrate. They're then pulled into the tornado, into the magneto-hydrodynamic structure, this plasmoid that's on the surface, and it synthesizes all of the elements that are stellar synthesis. And you can see the structure and where everything's working. And it's exactly the magneto-hydrodynamic structure. Then the particles that are coming off that, which we trapped, have chunks of tungsten, chunks attached to the stellar synthesis material.
Attached to what?
Stellar synthesis material, all the typical stuff you get: carbon, oxygen, nitrogen, sulfur, calcium, everything, titanium up to iron, right? The typical stuff. And in the tungsten itself, you can see what look like mid-Atlantic ridges with spheres slightly under the surface, expanding and smashing the tungsten up. And so it's the same process that's going on in the indium. In the indium, we see what looks like volcanoes all over the indium foil. And around the volcano is perfect octagonal indium oxide crystals. These were literally thermalized and blown out of the top and rained down and oxidized in the air. These were the visual ejections that you see, the eruptions. And then out of the volcano, you have these things that go like that. And it's made of silicon dioxide or a carbon plume, which has come out. Now, carbon should not be a fluid. It's either a solid or a gas, unless it's under extreme manipulation by intense electric fields. And I know this because I was accidentally included on a discussion with a scientist I'd never seen on the Russian community during the global thing that happened, right? And during this scientist had a picture with him next to Ken's shoulders, and he was talking about how they created a chamber in one of their experiments with an unbelievable intense electromagnetic field. And they had solid carbon at the below, but it started to produce these Taylor cones, and it fluidized in this regular array of vortexes. So under an intense electric field, you'll get these vortices forming, and it starts to fluidize the carbon. So, and this is what you see on the front of Matsumoto's book here. And so he used a pure lead wire, and he did typically three 80 millisecond pulses from 120 volts AC, 60 hertz. And it produced lead spheres, this lead sphere, and out of it, this is a pure carbon or carbon predominantly plume. So if you take 204, 6, 7, and 8 nucleons, you can make a lot of carbon nucleons from a base piece of lead. This one picture alone, and the similar pictures that we've shared from a range of different experiments, whether they're Vega experiments, these ones, or whatever, from the ultrasound experiments and also from the cavitation reactor of Binju and Huang, this amount of carbon cannot fit inside here. It cannot fit inside here. So it has to have been coherent matter in here, or it has to have been transformed nuclei of the original material. It has to have been. That's the only way it's possible. And in S.V. Adamenko's work from 2003, in his patent, he shows in his patent a beautiful iron-rich crenellated sphere chopped in half in the pure 5/9 copper, which is the accretion disk, where he hit with a 300 joule relativistic discharge through a hydrogen atmosphere and blew the top off this thing, synthesizing all of the elements in the periodic table from copper and actually from any other metal target they had. And he said in 2005, inside this iron-rich sphere, it's basically an iron sphere, there's a perfect hollow sphere. And in 2005, he said what happens is that the nuclear reactions occur inside this hollow space and due to dark matter. And the dark matter is the relic neutrinos. Okay? Mm-hmm. So you can either create it or whatever. Now, you asked, what I'm doing is I'm giving you the tools to understand specifically why it won't damage an engine.
Okay.
Why it won't damage.
Why it won't damage an engine. And the reason is because you're putting hydrocarbons in. And the hydrocarbons, the carbon that's formed prevents the damage to the engine. In the same, it thermalizes it, so it creates heat, but it prevents coherence. There is coherence in the clusters, but because the cylinder will have some carbon on it, it prevents the damage to a degree. I say to a degree because I haven't analyzed an engine, but what I can say is you can go and look at that without adding propane, 10%. To the HHO, it goes straight through tungsten. That's titanium. That's about as damaged as you can get. It goes straight through copper and brass. It decimates and disintegrates tungsten. There's nothing that can stop this. In fact, there is nothing that can stop it, right? Because the boundary layer of these microball lightning structures has a higher binding energy than all ordinary matter. And so ordinary matter just falls apart when it's in contact with it. And this is how an exotic vacuum object, a microball lightning, can literally go straight through something. Mm-hmm. This is what happens in the Usharenko effect. So you have a shaped charge, you put some sand in there, and you have some steel, and you explode it's an aluminium and petrol or something. I don't know. It's a very high explosive that they use. With you can go and look at my blog. I've got the Shishkin article on it. And essentially, some of the sand grains hit the steel. They form a plasmoid because of the critical impact of matter, and it goes 30 centimeters into the steel. 30 centimeters, a little sand grain, right? This is replicatable process, and it's a hollow chamber. And along the hollow chamber, the metal is vitrified all the way down with newly synthesized elements. So what you have is, if you don't want to create these things and allow them to cluster. So I have shown categorically that in the actual chambers of Malcolm's thunderstorm generator, there are pullers and givers. There's yang and yin. Yang appears to be on the outside of the inside, and the yin appears to be on the inside of the outside. The reason we know this is because on the outside of the inside, you can see these iron-rich spheres, but they contain chromium and molybdenum and nickel or whatever is in the steel that's used. But on the inside of the outside, they're almost entirely iron and just oxygen. And they're both, iron, oxygen are both magnetic or paramagnetic, and most of the oxides of iron are, pure oxides of iron are magnetic, ferromagnetic. And this particular oxide, FeO2, which appears to be the ratio, this magic ratio, which was discovered in 2017 in a diamond anvil at 1700 degrees and 270 gigapascals or something. I can't remember the pressure there, but it's something like a very high pressure. This new phase of iron is the highest oxidation state of iron. And so where is that, if that is what is there, where the hell is that pressure coming from? It's coming from the Magneto-hydrodynamic fractal structure. And that is the pressure at which it's pushing on all this matter that goes through these clusters. Now, I would not have got involved with this because we were already looking into the GEAT. The GEAT makes similar claims. The GEAT has a bubbler and it goes through a vortex and it has a counter vortex or whatever. And the GEAT's interesting because it produces, because you have a cone with the flow coming up this way, it produces a vortex one way, and on the other end, it has a bowl, and that produces a counter vortex. So the yin and the yang ball lightning structures are either end of the rod that they have in there. And so it basically atomizes all of the fuel coming in so that then it can do a cleaner burn. Okay, so essentially what I'm saying is by having carbon in the mix, we proved in 2019 that it doesn't do the damage to the metal. It does not do the damage to the metal, but it gets hotter thermally. It doesn't look as bright. It doesn't blind your eyes, and because the photons are a much lower energy. Okay. But it's actually thermally hotter, which is what you want when you've got a system that's based on thermals. You want to create thermal energy and have an expansion of gases. Okay, so in theory, it should make it more efficient. Now, so yeah, now I haven't seen the inside of a cylinder, but what was claimed by and sorry, the other reason is carbon gets deposited, and the carbon is diamagnetic, so it doesn't like to go into the structure. But like I say, when these structures get very close to carbon, everything goes in. But you're constantly giving it a more flush of carbon. In the outer part of the reactor, the actual heat exchanger, the thunderstorm generator, these structures can form on resonant nodes. And what do I mean by that? You've got vibration in there. You've got vibration from the engine. The beautiful thing about a sphere is sooner or later, you're going to have standing waves on that sphere, and you're going to have interfering standing waves. And wherever you get a standing wave forming in sound, you've got a perfect still area with oscillating vibrations surrounding it. And this will create the driving force and the ion acoustic waves that allow for these localization of these structures. And so they can build and build and build. So I didn't want to get involved with this. We were already working on the GEAT. And then someone sent me this video with these, what looked like plasma loops coming out of the thunderstorm generator and traveling over it. And I knew what I was looking at because I'd already seen this in our Vega experiments. And it's already been demonstrated in, wait for it, get this, a plasma flow, water flow plasma discharge at Bogdanovich et al. At the Moscow Nuclear Physics Institute. And they say specifically in their papers that it's a topological monopole at one end, or a monopole at one end, and the other monopole at the other way, and it's the flux loop between the two. And the flux loop can pass through matter. And because the matter, and that's what you're seeing with this wormhole. And if you go and look at our sample from a Vega experiment called cardioid infarction, you can see where the spin nuclei of copper 63 and 65 is pulled, goes through a wormhole, just as Matsumoto derived, and splats down, punching a hole through the other side of the magnetohydrodynamic vortex and splatting it down and depositing it exactly in the pattern of one half of the magnetohydrodynamic vortex on the ferromagnetic ion. So for me, it's utterly conclusive. It's utterly conclusive. The process is a real thing. Okay. So now the question is, does it have utility in this particular device? Well, I would like someone to send me the internals of the cylinders. Certainly with the Geet, Paul Pantone claimed that the engines were cleaner inside and they were not damaged. They actually had less wear. Okay.
Mm-hmm.
So this is better than bad. But I can't say that because I get the same story from Malcolm, but I don't, like I say, my approach is I hear what you say, but I want to do my own work.
Yeah, yeah.
All right.
So couldn't you get access to one of the motors that have been used for the testing?
It's not like I haven't asked. So I think
Okay.
we have to do this for ourselves. So
Okay.
when you've been able to run a test for a long enough time,
Mm-hmm.
we want a raw engine, and this has cost money. You have to buy a raw engine and have it looked at, and then and ideally the same engine, but then you don't want to break it up. So you want two engines, and you want to literally just cut one up and see what it looks like before you do anything. And you want to do one with the system, and you need three engines. You need a before, after with and an after control, which is just run normally
Yeah,
for a
yeah,
similar amount of time.
yeah.
But when you're looking at the prize here, the prize is so massive. It's so ridiculously massive. It's rude not to. And it's about having the guts and the determination to go through the work. Now,
Mm.
I have very
How long should the engine have been run before doing
well.
the test?
This is where the good news comes, because the more time you run something, the more difficult it is to determine what's gone on.
Okay.
You actually don't want to run it for a long time because when you get an event occurring and then you have another event on top and then another event on top, you can't discriminate what is actually the process that's happened. Which is why when I look at something that's been damaged by this, I always try and look at the periphery, because the periphery has got the end of the bell curve. You've only got a couple of impacts on the periphery. In this system, what is the periphery? Well, we're looking at the inside of a cylinder and probably the piston head itself. And so those are the things that you need to be looking at. And so you really only want a few events. So that's the good news. And the good news is for the control and for the pistons, you don't need to damage them, but you kind of do need to take a section of the cylinder. That's where you end up damaging an engine. But it's just someone's got to do this at some point. And Malcolm honestly has always struggled to get a operational device for the demonstrations wherever he's been. And it's not like you can easily put a petrol engine in your baggage and carry it. So you have to build it on site. And then when he's got a particular unit running in a particular jurisdiction, he doesn't want to break it up. And so I can understand, but like if you're going to be serious about this, if anyone's going to be serious about this, they have to do the work on actually, because you want to have a conversation with these people and say, look, based on our tests, this is the before, the after, and here's the control, and this is what we see. It's either less or more or better. That's the work that has to be done by someone.
And how should this testing be done? What would you look for?
I would look for the impact marks and the damage from, just like I have shown on the actual heat exchanger. And you can see, so in Benjamin Huang's reactor, he got very disappointed because I predicted certain things were going on, and it turns out exactly that was going on, which is good news because it has a means to produce the excess heat, and it's the same process. But what we've seen these 15 aside or 20 aside apple shaped, no, it's 15 aside apple shaped parts of the fractal torus, and they've crashed down on the copper, and that one has broken up, and as it's gone through the copper, it's taken 100 to 200 nanometer layer of copper and wrapped itself around it. This is supposedly a water vortex, and it is tearing copper from the metal. In its actual vortex that's going in, you can see the cone of copper that's been literally ripped out of the metal. In other examples, you can see where the fractal torus has come down and you've got the surface of the metal and the tornado, the disruption beam has come down. It's engaged just like a normal tornado does, and it's the same process. See, when people see these buildings disintegrating in a tornado, and then they see a piece of, dry wall coming up into the air, and the dry wall is floating in the air. Nothing is hitting the dry wall, nothing at all. It's in free air and it's even just drifting, but it's disintegrating in midair. Why? Because these natural charge clusters have been ripped into the lattice of the gypsum, is overexciting all of the chemical bonds in there, and they can't maintain their structural integrity, and it just disintegrates. Nothing is hitting it, it's falling apart in midair. So this is the point. And so what you see is the tornado touches down in the Binchuan reactor and it starts ripping up copper from the surface, pulling it in. And as it's pulling it in, there's a vector pulling the overall structure down, and it ends up crashing into the surface and embedding itself always 50% in. Because when you're 50% in, the Magneto-hydrodynamics are pushing it out as much as it's pulling it in. So it becomes equilibrium. It gets stuck in the metal. These things get embedded in the metal. I haven't seen those. I've seen the impact on the outside of the inside of a thunderstorm generator. And it's typical. You see more damage on one side than the other, just like you do in an ordinary tornado. On the side,
does it impact on the generators or the thunderstorm generators performance?
This is how it works, because all of this is going on in the exhaust area. So there's high activity in the exhaust area. So here we go. You create water coming in. Now, this is where I depart and have consistently departed from Malcolm's hypothesis. And I've told him very clearly, and I've told the public very clearly, right? He still has his hypothesis, but I don't believe it's necessary. All of these systems, you want to vaporize the fuel as much as possible. Well, there's technology going back to the 30s for that. Adding water, technology is going back to the 30s. You need to add moisture. Moisture, for several reasons, it lowers the temperature, higher density gas in there, better combustion, right? And there are patents that have expired that show this work from the 70s or 80s or whatever, 80s or 90s. They're expired. Adding moisture, systems to add moisture, okay? There are, and I can send you a couple of patents. I've discussed them. I can't remember them offhand. Okay. But my first presentation, before I'd even seen one of these tested, Malcolm said X, Y, and Z. And I said, well, I can see it's got this thing coming out of it. And now I need to be interested because those things need to be shielded. And you don't want to be driving your reactor such that the magnetic flux loops are coming out. In the GEAT, they said if you brought your magnetic credit card strip within a certain distance of the reactor, basically it wiped it. Right? You can't see the intense fields, but it completely disrupts the magnetic information. And this is the same with anything, right? So, and also in the GEAT, he had some water on the ground and the GEAT's running up like this. And you can go and see it. He described a tornado coming up into the top head of the GEAT reactor. And the reason is because it's a fractal structure. It has the vortex beam that comes down the metal rod, but it also has a minimum of vortex and anti-vortex at the top. And when you orient that towards the ground, there is a torsion beam that comes down. And what you're seeing is in this, the main wheel is made from two wheels, and wheel and an anti-wheel, right? And this one is also made that because it's fractal. And so what you're seeing is the tornado of water moisture is one. The water is split not by electrolysis, it's split by an over-excitement of etheric matter. It goes through, the electrons are then forced into a state where they behave differently, and the water falls apart into hydrogen and oxygen. This is, I believe, why vibrating cavitators producing oxyhydrogen gas are far more efficient. And there's a thing called the Davy cell where they literally used sound, only sound. Okay, you're going to get cavitation out of there, but it was like a half sphere with another half sphere inside it. And by vibrating it at a certain temperature, he would boil water. the Schaefer steam generator would boil water. And yes, there's some boiling going on, but the work can be done by water that can't hold itself together because it's excited. You know, when water becomes gas, it expands 1,716 times. It doesn't have to be hot. It just has to be gas. You understand? And when it's gas, it's cold expansion. It's freaking amazing. That itself is a whole other area of physics that is enabled by this. So what's happening is one of the sub-tori in the top structure in the GEAT reactor is producing a torsion beam that's pulling chi through that water, turning it into water vapor, and that is then getting caught in the tornado. Now, the interesting thing is this. He describes going to touch the top of this tornado and getting a fantastic electric shock. Why? Because when you break up matter, you can release this extra thing that can become electrons. It's part that drives the actual way that real thunderstorms work. Right? Malcolm doesn't know any of this, right? I try and tell him, but anyway, a lot of the understanding is right there in the Book of GEAT and in the testimonies of Paul Pantone. But he saw these anomalies but didn't understand them, right? He would explain them in the best of his ability, which was, thankfully, he was getting out there and telling people about this. It's in the record. So this is where I come to the Armstrong electrostatic boiler, which was my first point before I'd ever seen an operating unit of how I believe this is working. The Armstrong basically made Britain the empire it was because they made all the military weapons, right? They were based up in Newcastle and other industrial towns during the Industrial Revolution. Okay. Now, there was this steam boiler in some sort of manufacturing place in Newcastle where there was these huge electric arcs seen like lightning. And when they got down to it, they found that what was happening is these arcs were formed because of a crack in the steam boiler, and the steam was rushing through that crack. And somehow this was leading to the production of these large arcs. We're talking about the 1830s here. This is very, very long time before Tesla ever created Tesla coils, and even longer before the Van de Graaff generator. Okay, so they made this thing called the Armstrong electrostatic boiler. And essentially what you did is you had a coal or wood or whatever you could burn boiler, which produced high pressure, supercritical water and steam that would then go through and flash water to steam. And then it would go through a circuitous route through a wood nozzle with a hole drilled such that it would produce what the Russians call a cavijet, which is where if you have a fluid moving through, because of the shape of the nozzle and the output, you end up with a pulsed ejection, which forms solitons. It forms smoke rings. And they developed this for mining in the oil industry, where if you were using a intense pressure jet to mine into rock, using the same pressure, you could mine 4 times faster by having pulses. And they have it on video, and I've done a whole presentation on this. You can go and see it with the patent. The patent's expired. So I'm talking about everything that's patent's expired, but they show how the principle works. So the cavijet produces these solitons that are like a water hammer, but then water hammer solitons, and the solitons are very high integrity. They don't want to break up. They want to continue moving forward for the same reason all of these structures do. Now, in the case of the Armstrong electrostatic boiler, when that came out, the steam came out, it's effectively supercritical water. It wants to be steam, but it can't be until it gets to the low pressure air, and it flashes instantaneously to steam, becomes this intense vortex, but the ripping apart of that water and so on creates charge clusters. And because it's an electrodynamic structure, even if it's just water molecules moving around, because they're polar, it produces this magnetohydrodynamic structure that focuses all of the electrons into the center. They go round and they get focused into the center. And then on the other side, they have like 5 nozzles over here, and they have 5 nozzles over here. They have spikes. And the solitons then hit the spike, and all of the electrons that were in the core get captured. And then they go into a ball. They get captured into a large electrostatic accumulator, a sphere. Mm-hmm. And this thing in the 1830s could throw 2 feet sparks. That's 1.98 million volts. Okay. Nearly 75 years before the Tesla invented his coil, and 100 years or whatever before the Van de Graaff generator. So here we have just got flashing steam is producing extremely high voltages, extremely high, large amounts of electrons. Where the hell are they coming from? Where the hell is that? So I suggested to Malcolm that he wants to take his whatever excuse he's got for making a long thunderstorm generator and make it smaller. Because I said you want to get the hot near the incoming moist air as much as possible. Because you want to have the most intense flashing to steam as possible with the axis of hydrodynamic shear this way and the axis of hydrodynamic shear that way. Axis of hydrodynamic, that's multi-axis hydrodynamic shear. That leads to the production of the exotic vacuum objects. It's, in my view, nothing to do with the bubbler other than providing moisture, and nothing to do with the light, which is not an ionizer. No offense, Jan, you've done a lot of work on that, but I don't think either of those things are actually necessary. Okay. And they're not patentable. They're not patentable because those works that work has already been done in other patents that are now expired. The bubblers, like, why even bother? And even there's a guy who used a pond mister, but that was already used a long time ago by people doing spark. You have these people like Aaron McCarmy, I think it is, and he has a spark plug, and he produces water vapor, and the water vapor goes in the spark plug, and the bang is far more intense. Why? Because you're instantaneously flashing that water vapor to steam, and you're creating a micro system of the Armstrong electrostatic boiler. People don't understand where all the electrons are coming from. I've told you where they're coming from, right? And the electrons are what then does the self-organization in the multi-axis hydrodynamic shear to produce the plasmatorids called plasmoids.
Okay. Bob, did you just say, why even bother with the bubbler?
I'm saying, see if it works. And then this is what I would recommend.
Yeah.
Just get a water vaporizer, and then use that. And see if it makes any difference at all.
There was an event at the testing that was done in the US last year.
It wasn't working, and it still did the same results. I know.
Exactly.
I know.
Yeah.
So
you don't have to ionize it.
There's no ionization going on with that with that light bulb. I always said that. I said if you want ionization, you have to produce a higher frequency of light. Those light bulbs. You go and look at my very first presentation. I said that this is not a frequency that will ionize any of the gases in air. I said at best it's going to be exciting them. Right? I said if you want to try and get it to a point of where it might be doing some ionization or something useful, you would use titanium oxide and use the photoelectric effect to produce some electrons. And the electrons would energize the air a little bit. So what you've done is what I would call a control. But you've done a fantastic job in simplifying what Malcolm is doing. And Malcolm should be adopting what you've done. It's a great simplification of what he believes is going on. But I would argue that the Armstrong electrostatic boiler and analogues of that did not have any means by which to ionize or energize air, and it just had water flashing to steam through a crack, which produced multi-axis hydrodynamic shear. That is the process. So then when you've got a huge quantity of free electrons, which I believe are coming from within inside the protons that are split from the water, and critically, I believe that the structures that are formed that then go into the chamber, when you do the charge, the spark, The spark is what actually makes the magic. It causes a critical disruption of these neutral clusters that are bound to the oxygen that are coming in, that then synthesizes a vast number of electrons that go on to produce more of these clusters. Because if they, what happens when you blow up one of these, you've got one hydrogen atom, you split that to an electron, a proton, and this cluster. You can go and see it on just search Sishkin on remoteview.icu. You can go and see it and look at his work on these energy clusters. Then when I said this in 2022 in Azizi, when you what the Russians had found out is that you only need an impact of over 5 electron volts. So that's just over the energy at which you need to split hydrogen and hydrogen. If you hit a atomic hydrogen with over 5 electron volts, it'll split into these 3 components. And then you need to hit again the cluster to then release up to 10 to the 11 electrons. And this is the same as you get from an exotic vacuum object, right? It's the same maths. But the interesting thing is, each of those electrons that are emitted are up to 10 kilo electron volts in kinetic energy. Why? Because they are in a coherent state in the cluster. And when you break up the cluster, they're neutral because they're in a coherent state. When you break up that cluster, the electrons come out at up to 10 kilo electron volts because of the Pauli exclusion principle. They absolutely do not want to be next to their now fermionic cousins, right? And they come out violently, and 10 kilo electron volts is, drum roll, a hell of a lot over the 5 electron volts you need to do the same to all of the other clusters that are in the chamber. So you produce a huge amount of charge in there. In this multi-axis hydrodynamic shear, the carbon keeps everything in check, right? It forms clusters. And go and look at what Anatoly Klimov shared at Alexander Parkhomov's birthday. I translated it using AI. It took me about a day to do these 2 bits. But he showed that in his Ken Shoulders advised a device called the plasma vortex reactor, that you do not need to use metal nanoparticles as fuel. You can use, drum roll, carbon. And it becomes the fuel. The nanoparticles, the fuel. And the best way to get in the nanoparticles is to put in a hydrocarbon vapor, even a gas. And it splits it. You have loads of literally single atoms of carbon. They're ions. They can get pulled in because they're ions into the structure, and the magic happens. He even produced a CC laser in 2000 and 2001. It's the first time he's ever shared it, because he's a little bit, I would argue, sorry, Anatoly, if you watch this, I think you're suffering because you can't monetize all this brilliant work you've done. And he's in a situation where he worked prior to the thing that's going on in Eastern Europe. He worked with this group called NetIQ, and then NetIQ, parts of NetIQ split and formed Ngate, and NetIQ and Ngate have got subsets of his technology that there's some in the process of commercializing in the West, and it must be incredibly frustrating for him. So he basically came out a couple of weeks ago and said, look, we went a hell of a lot further than what we shared, and we're stuck here in a country that relies on revenues from oil and gas. Like, no one's interested. He's in a terrible situation, but he tells you that carbon nanoparticles are the fuel. So what I'm saying is, you create many of, in his case, he has a Tesla coil producing the high voltage discharge. He produces a specific supersonic vortex to keep the material away from the quartz of the chamber. That also is producing, because it's rotating this way and it's traveling down the tube, that's multi-axis shear. And so when you start burning that, it then burns, produces clusters, and does the magic. Does the magic. It's the same thing. It's the same thing. It's the same thing as the PAP engine. All of these things are the same thing, right?
Bob,
go on.
I must say it's fantastic to listen to. I'm highly engaged, but I have to leave now.
Oh, well, I'll send you the recording.
But
what questions do you have?
Yeah, no objections. It's fantastic, but our basic question has been answered, right?
Yeah.
More testing is needed, really. If one wants to go to the maritime shipping business, you cannot sell it in at the present situation.
Well, you can
The
always
way
sell
I
things
read.
if you don't know what the problem might be.
Yes, but we need more testing, right?
Yeah,
But
I think that's a prudent thing
one
to do.
question before I leave. One question before I leave. Malcolm also says that he has scrubber technology. Is
This
that
would be the scrubber
developed
technology.
yet, or is that
I,
just an
I don't
idea?
know. Malcolm says is a whole different category of thing,
Okay.
right?
Yeah.
Like I don't believe anyone when they just say something. Show me the technology and
Okay.
let me judge it.
Yeah.
And I might be wrong in my judgment, but I've been very lucky. Let's put it that way.
Yeah. But
Um,
before I leave, I'd just like to say that it's fascinating what you're saying, what you're telling us. So I'd hope we can get our prototype going shortly, and we can stay in touch to do more investigations along the line.
Absolutely, and
Yeah.
and I really think the best way to be with your findings is to be open.
Yeah.
I'm hoping to. We have an option on a scanning electron microscope for about more than one third off. It's the one that I've used to share all of the data over the last
Yeah. Yeah.
recent years. So we get if we can buy it, we can get all that money back. So we have a person in Prague that might be able to buy it on our behalf and get
Yeah.
everything that we paid back.
Mhm.
And I would like to analyze those. If you can, it's still going to cost about 100,000 euros, but it's not
Yeah.
150,000 euros. So,
Okay.
and so if you can do the work on the cylinders, assuming we can get that,
Yeah.
I'll
Yeah.
be
We
happy
could.
to
We could
analyze
do
them.
that.
As usual, I'll be doing a live recording, and in fact, on Thursday, I will release a whole bunch of videos of analysis that I did last year on the Malcolm Bendall and all the raw data sets for you to analyze. And I think that will be a really good resource
Yeah.
for you.
Of course, Sten has access to the Danish Technological Institute, and we could do
Wonderful.
some analysis there, I guess.
Wonderful.
mhm,
Okay,
mhm.
but thank you very much for the discussion so far. I'm sorry I have to leave now,
No
but
worries. No
we
worries.
keep
That's
up
fine. I'll
the
carry on with
good
the other guys.
connection, right?
Yeah.
Okay.
Okay,
Cheers,
okay.
Jan.
Thank you. Where
Perhaps
do I?
a question regarding testing again
Yeah.
for the internal surfaces of the engine. Um, you mentioned that we don't need to run the engines for that long time.
It would
But
be ideal that you don't.
if you have the control engine, why wouldn't you run it for a long time? I mean, what licensees would like to see is what is the long-term effect on engines?
Well,
Uh,
I want to see whether there's any effect early
yeah,
in the process because you can
yeah,
extrapolate out. You can run the control engine as long as you like. Yeah, of course, right? But again, there is a chance that a normal engine will produce some of these effects anyway. You've got a spark discharge, you've got some moisture in the air, you've got so some of this might be happening anyway. And you don't want to get into a situation where you're assuming that what is damage caused by the flashed steam and possibly the where he thinks the plasmoids are coming from in the bubbler, it is coming from that, and it isn't actually just naturally there anyway. So you need to have that data point to make a
mm,
argument.
mm, okay. And the testing would be by a scanning electron microscope or
That would
microscopy.
be how I would do it because I can then compare it to other data sets from different experiments and because I just know what I'm looking at now and
Hmm.
if you
Hmm.
look at the live videos where I've recorded exactly what I've done, you could do it as well actually.
Hmm.
But I can look around on the thing. I can take a scan. I go right. That's an Evo mark. That's an Evo mark. That's an Evo mark. That's just a layer of carbon and
Hmm.
you get a feel for it. So
Yeah, yeah, yeah. And I also wanted to ask about it's quite fascinating what you have laid out here. I have to confess that I can't follow everything because I don't have the physical background to follow everything you said. But my question would be if you could at some point in time, would it be possible that you could sort of lay this out in a report, um, a few pages of report to sort of lay out the theoretical evaluation of possible engine damages. Would that be possible for you to do?
Everything's possible. I'm
Yeah.
pretty tied up this
Okay.
year, I have to
Okay.
say.
Okay.
And I have to respect my family, so
Of course.
I have to do a balance between earning a living and giving everything that I do away. Um,
Mm.
yeah, so everything you need to know is already published, actually. And in
Yeah.
this video, I've given you probably quite a succinct, and you'll be able to review this video again and
Yeah.
take
Okay.
notes down. I will post the video with the references to the specific patents that I'm referring to, even to
Hmm.
videos of Paul Pantone talking about what he's done in the past and
Hmm.
so on. So there is very specific things where you can learn from, and just don't take it from me. If you look at also the interaction in the Binger and Huang materials, you can literally see how these things are wheels within wheels within wheels. And because of that, the electrodynamics allows the magic to happen. And for the
Hmm.
formation of a wheel within wheel within a wheel, you necessarily have to have the multi-axis hydrodynamic shear. And for it to be an electrostructure, you need at least polarized material, of which water is. And so I'm not saying, and it will be the case, that in the water hammer effect that's allowing bubbles to be formed under low pressure and collapse, you're going to get some effect going on in the bubbler, right? Ideally, ideally, the bubbler should be at around about 70 degrees centigrade.
Hmm.
Why? Because at 70 degrees centigrade, this is the temperature that was used by Mizuno when the Lena effects start occurring in Mizuno. And it's also the temperature that Binger and Huang raises his deionized water to when it is actually being fed into his Venturi, his water injector. Why? Because when you go from the normal pressure to the low pressure, and in that 70 degrees, it immediately flashes to steam at 70 degrees.
Hmm.
So you enhance the effect of producing the flashing process. I believe this is why in the Geet, when he fed the exhaust, which was partially cooled through heat exchanger, into the water, over time it raised the temperature of the water, becoming more efficient because it can actually produce some of the charge clustering effects inside the water bubbler. This does not happen with Malcolm's system. It does not happen with Malcolm's system. You're reliant on normal ambient temperature of the water and any potential. I mean, if you're expanding and compressing it the whole time, you're sucking in heat and you're pushing it back out again. Um,
Hmm.
you might get some cavitation related heat, but it's not optimal. So I think in many respects, the feeding back of some heat into that water would accentuate it. And you could try that experiment. But here's the thing, you can produce water vapor in a range of ways, and one of them could be hotter water vapor coming in. The other thing
Hmm.
about water vapor is when it cools, it actually provides cooling for the engine. Like if you
Hmm.
literally have nanoparticles and microparticles of water coming into the engine, when they actually do flash to steam, it actually cools the engine. So it's got a
Yeah.
protective effect on thermal based problems
Hmm.
that
Hmm.
you get in engines.
Yeah,
That's,
I believe Jan could do some experiments in this direction here.
Yeah, I mean, he would need to use a different chamber than Perspex.
Hmm.
No, the Perspex might be able to raise to 70 degrees. He would have to think about his 3D printed and his rubber things, but you could try
Hmm.
some performance. And then the last one is a bit of a bone of sticking point between Malcolm and I because he flatly is resistant to talking about it, and I just saw it. So a guy, Phil Dubois, who you'll see on discussing with me, because he came and did some of the analysis. A point being was, people say, well, I've seen these iron-rich crenellated spheres, and I'm the person that found them, so maybe I'm spiking the sample. So he cut from the 24-inch sphere himself several samples. He packaged them, so no Malcolm involved, no me involved. He got on a plane, he flew over here. He had custody of those things the whole time. He put them in the SEM. We look at it, iron-rich crenellated spheres, right? So in the videos, he's with me. He then went away after that period, and he did some experiments where he found a counter vortex going in. Okay. Now, some Germans tested a thunderstorm generator, and they found that they weren't seeing the gains in their tests. And I'm not. I didn't do the tests. I wasn't party to them tests, but their tests, they put a freaking huge bag on the outside, and they found out that after a while, it wasn't producing the claimed benefits from the thunderstorm generator. Well, this would be true
in terms of energy consumption or energy
in terms of output gases.
Okay.
Now, if you're eating your own shit, you're going to end up shit, right? So here's the thing: a normal catalytic converter has something that removes the oxygen from the nitrous oxides and nitrogen dioxide, N2O and whatever. And then it reoxidizes the carbons, monoxide, into carbon dioxide on the output. So it's a two-stage thing. One's like rhodium, the other one's platinum, and they need to be hot to do the process, okay? But effectively, they're releasing oxygen that's already embedded in the material. In this overall system, if you're injecting some extra water, you get the extra pressure from the pressurization, you get the extra pressure from the production of potentially of these electrons from the neutral clusters that are being released. And you also get, I lost my thread of thought there, which is unusual.
But the extra, can I just ask, the extra pressure could that in principle damage the engine?
Well, then you change your injection.
Okay.
So this other pattern, which injects, it's a humidifying pattern. He was a military guy, and he wasn't allowed to ever make money out of this technology. But he actually has a regulator in a Venturi that changes the amount of moisture that comes in. The problem with Malcolm's system so far, he manually gets a sweet spot, and then people argue it's just because he's doing a lean burn or whatever. Okay. You want a system that can run over a range, particularly if you're running an engine that's actually not just generating power, it's trying to drive a car or drive a ship or whatever. You need to work over a range of power draw from the ICE engine. So his system overcomes that process, and it is only introducing the moisture, right? So you want a system like this that's doing that on the input to the thunderstorm generator. And so it's regulating the moisture.
But you were explaining also why the German testing failed.
Oh yeah, let me get back to that. So it didn't fail. It failed when you're sucking the same air from a very big bag, which means so you're getting, if your protons are combining with some electrons into making neutrons and converting your oxygen 16 to oxygen 17, which we've observed in Binju Huang's reactor, and I believe is what caused the carbon arc underwater with oxygenated water for Sundaresan and Bockris to produce iron in 1996 in that low-energy nuclear reaction experiment. It's the production of oxygen 17. You are then taking hydrogen out of the mix, which leaves you with a net balance gain of oxygen, right? So it could automatically do a cleaner burn for that respect, in that respect only, because you're getting extra oxygen from the water. Right. So you're getting extra power, and then you're getting extra oxygen too, and then you don't need your catalytic converter. But what was claimed by Philip Dubois was there's this counter vortex. He threw it on me when we were doing the isotopic analysis using quadrupole mass spectrometer in California. And I said, well, I hear what you say, and I like you, but here's the thing. I don't believe anything until I've seen it. So we did the test the following day, and sure as hell, there is a counter vortex. And the thing is, the counter vortex can be, depending on the cycles of the engine and whatever, the counter vortex can be fixed. So you could put a probe here, and you're measuring like if you can imagine a spiral coming in, a spiral coming out, there can be a spiral going in with the counter vortex. Okay. And so with the spiral coming out, if you put your probe in a particular place, then it's only measuring the air coming out, but it's ignoring the air that's coming in. Now, here's the thing. I was in for 4 hours in a warehouse in East London and I didn't die. They put me in there with a normal engine. And I had asked for a carbon monoxide and so on monitor. And I'm thinking, why am I not dying in this room? I mean, they had the door cracked, but like carbon monoxide is lighter than air because O2 is heavier and N2 is heavier than carbon monoxide. So it's lighter. So it fills in from the top down. So it should have filled in because the door was only cracked at the bottom. So it should have filled in from the top down and started to suffocate me. And it didn't. So I decided to go over with this detector and put it 2 inches from the exhaust. And it was barely over 70 parts per million. And you can breathe 25 parts per million for an 8-hour day, right? So it's just 2 inches from the exhaust. So I revealed this and then the following day, and I said, Malcolm, can we test one of the control generators? And he said, okay. And he pulled it outside and he turned it on and it was about 5-6 meters away from me. And already the detector went over limit. Not over limit, it went over the units that I was measuring 2 inches from the exhaust. Okay. And then he moved over to the wall, and I read in the manual 3 times it says if you don't have it more than 15 feet away or something from your house, you expect to die type thing. Don't have any open windows or open doors. And like these generators are used all over the world, closer than that in many cases. People don't read manuals. Okay. And I went over to it 2 meters from it. It was 500 parts per million and over limit because it only reads up to 500 parts per million. That limit, you're dead and there's no recourse in a very short period of time. So the warnings are very clear in the Honda manual and they're very accurate. So how is it that I can be 2 inches away and I can breathe that for a long period of time, 3 or 4 inches away and I can breathe it for an 8-hour day? How is that possible? Well, it could be that it's sucking extra oxygen in and making sure it's doing a clean burn, which is still a good thing. It's still a good thing.
Yeah.
And so we tested it. It's definitely coming out. Now, if you put a big bag on the end there, it's going to suck all that oxygen out. It's doing air exchange with the bag. And over a period of time, it loses the extra oxygen that it's gaining from the air. Okay. So
if you have the engine in a closed room, it will suck the CO in into the engine?
Well, there's only 0.04% of CO in the atmosphere. It's basically not there. It'll suck in oxygen, which is 20.87% or something from the air, and it's basically breathing a bit. So it's not only doing everything that it's doing in the engine and also all the water dynamics, it's also doing some breathing. Malcolm doesn't.
So is the CO is the carbon monoxide oxidized to CO2 or?
Yes.
Okay.
So this part of the story is dealing with what is the most important thing that they do with normal engines. And I didn't realize this when I was actually talking about my experience. The engineer at Land Logical, the reason that they have a problem is that they're inside the M25, and so they can only produce a certain amount of carbon monoxide in a volume of air, right? So if they can reduce the amount of carbon monoxide by 10 times, then they can run 10 times more generators at peak time and produce 10 times more profits on the same space. They have generators, but they can only run a certain number of them because of the limits on the amount of carbon monoxide they can release. There's a limit to that. But if they reduce it by 10 times, they can run 10 times the amount of generators because they have the gas. They have both natural gas supply and landfill gas, right? And they can run those and they can sell as much peak energy at a higher price as they want. So it's literally a license to print money just on reducing the CO. So it doesn't matter if it's this process going on. And this is what he told me is, and this is long before this understanding came along. When you go to a motorway, they don't let you stop on the motorway in the UK. And in fact, in many countries. And they say it's a hazard risk because a car can crash into you. No, if you go and stand by a motorway with a carbon monoxide monitor on, it's lethal doses. The monitor goes off. So even with all of the EU emissions and limits, it's still lethal doses if you stand by a motorway. You should only stop in emergencies,
Mhm.
because you're going to die anyway, or your car isn't actually working. So here's the thing: it fixes a huge problem all by itself.
Mhm.
We know
Mhm.
that it's producing the iron-rich crenellated spheres. This is where the nuclear reactions occur inside those structures. So we know it can do that. But in addition, I call it like a cheap catalytic converter.
Yeah.
Who's not going to want a car? Because basically, ignore all the nuclear stuff. The catalytic converter aspect of it, you don't need the platinum and the rhodium. You don't need to use 25,000 miles worth of gas to refine those precious elements to make the thing that you put on your car. You're
Mhm.
immediately saving a huge amount of hydrocarbons by not needing that. Because it's so even with this aspect of the story, it's a huge win. And it's the major problem in Indian cities. Because in Indian cities, the P10, P5, and P1 particles and the carbon monoxide are killing the kids' brains. They don't even know
Mhm.
it's so bad. But if you go there as a Westerner to Ahmedabad, where we were, within a few hours of being in the center of Ahmedabad, your head hurts with a blinding headache, and your eyes are streaming, and your nose is streaming. This is a real problem for people in cities all over the world, just that
Mhm.
alone.
Mhm. Mhm.
And it's not that there isn't plenty of oxygen, it's there's lots of particles in the air and lots of carbon monoxide that otherwise could be cleaned by just an engine that works a bit more interestingly. And because
Yeah.
you can't put a catalytic converter on a rickshaw, you can't fix it. You
Mhm.
can't put it on a two-stroke engine, but at variations of these devices, you could.
Mhm. But still, to get back to the this German test, um, given that one source of error was that they had the CO oxidized to CO2, but still they didn't really measure any reduction of CO2, did they?
I don't know how much they shared, but I need to go and look at their report.
Okay.
It wasn't made public. They were going to present at the next Austrian conference, but they withdrew because of this particular event because they put a bag on it and then the magic went away.
Yeah.
At least in the major aspect of getting rid of carbon monoxide,
Yeah,
but
they
there's
would
no explanation for it.
they wanted to present that in Stuttgart, I think, and then they withdrew, right? Right.
Yeah. So
Yeah.
so
Yeah.
they didn't have an explanation for it. I'm giving you the explanation because we didn't know about the counter vortex at that time.
Mm,
But
mm,
Malcolm doesn't like to talk about this story, and I just think that it's stupid because I'm not saying he's stupid. I'm saying
mm.
I think it's stupid because it's an incredible story in its own right.
Yeah. Yeah.
It's removing the need for expensive precious metals. I mean, people often crash and write off their car before they've done 25,000 miles. So like
Mm,
they're net negative just on their catalytic converter. And it
mm,
makes possible the ability to put cleaner burning on dry bulk carriers.
mm,
If
mm,
you can better burn and recover some of that energy from the carbon, like you've got a fuel stack, so you've got an exhaust stack, and rather than chucking all those P10, P5, and P1 particles into the atmosphere and the carbon monoxide that comes from that bunker fuel, right? You can burn that and return some of that energy into the engine, but keep the engine cool because you've got the water that's flashing to steam. You're then going
yeah.
to be running more efficient and clean. And you don't even have to talk about nuclear. That
Mm.
might be a bonus
Why? How could you avoid talking about the nuclear?
because you say it's an advanced catalytic converter without having to have 2 tons of precious metals in your ship, or however much it would be. I don't know how.
But 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 still, we need to explain how we get rid of the CO2, right?
No, well, CO2 is not a problem. It's a problem for the how should we the prevailing narrative. But pure
Yeah. Yeah.
CO2 is a plant food.
Mm,
You can breathe CO2 up to 6% and it's not going to kill you. And it's 0.04% in the atmosphere. It's basically not there, right?
mm,
CO2 is,
I completely agree, but the authorities want us to reduce the CO2. That's the problem.
yes. And I'm saying that there is this potential thing that it's doing with the nuclear side of things. But I'm
Mm.
saying before you even get to the nuclear discussion, which is a hard one to have, right?
But
For
now we have
other reasons.
your paper to justify it,
Yes, that's true.
your
And
science report
yes,
paper.
yes, yes, yes. There's nuclear reactions going on. Of course, it's a slightly different system, but of course we've
Mm.
got this work as well,
Yeah.
and so on. And we've
Mm.
now got very, very simple experiments.
Yeah.
So, for instance, this guy who's calling himself by Tibby, he's an electrical engineer. He's made an even simpler experiment than the Ultra experiment, the ULTR experiment. That one needs a $35 piece of equipment. His experiment uses a 4,700 microfarad capacitor charged to 30 volts. And then you get an insulation square and then a piece of aluminium foil below, a piece of aluminium foil above, with some deionized water in between, and you just spark. And it produces loads of little microplasmoids, and it seems to produce the iron-rich crenellated spheres. This is a zero barrier to entry demonstration. We're still working on whether it still produces all of the key effects, the iron-rich crenellated spheres, and if it does any transmutation. But if we can demonstrate that even the production of the iron-rich crenellated spheres, if it's producing it from contamination iron in the aluminium, it doesn't matter. It tells the story of intense magnetic forces, ridiculously intense, that it can cause the production of glassy iron from fragments of iron in aluminium. That is mind-boggling, right?
Mm. Mm.
And the experiment is so simple. I mean, whilst a 3-year-old can do an ultra experiment, because you're using a spark discharge and some bits fly, you need to be maybe about 8 or 9 or 10 or rather. But but we're now at a level where it's essentially free. You can extract a capacitor from an old piece of electronics at the dump. You can go to their battery bin and take 4 or 5 9-volt PP3 batteries. It doesn't matter if they're good ones. You can gang them together and they'll be able to charge a capacitor. And then you just need some distilled water, which you can get about $2, but you can make it yourself at home. But it's better to if you make it yourself at home, you have to shake it to put some oxygen in it because the oxygen is key, and then run the experiment. We're at a point of we've gone beyond the sort of looking through the telescope part of the change in the heliocentricity to heliocentricity. We've got to a point where you literally have to have no desire to find out that this process is possible. And what have we got
Mm.
there? You've got a spark and water, spark and water.
Mm.
That's
Mm.
what's going on in the thunderstorm generator.
Yeah.
That's what was going on in you know the water car, spark and water.
Yeah. Yeah.
But he used a laser to create the charge clusters. The laser comes in, splits the hydrogen and oxygen, splits this neutral cluster, and also impacts it to produce all these free electrons, and they do the work.
Mm. Mm.
We're getting to a fundamental understanding of how all over unity technologies work. And Malcolm's system is potentially a small inroad into leveraging that with the current transportation rolling stock.
Yeah. Yeah. To get back to the question of changes to the surface, the inner surfaces of the thunderstorm generator, you mentioned that it wouldn't sort of deteriorate the operation of the generator over time.
Very specifically, I'll reiterate what I have said and what I maintain. The claims by Pantone is that the engine ran cleaner. This is also the same kind of claims that were given to water injection in aircraft and diesel tanks during the Second World War, right?
Mhm.
But because of the extra power and because it's not designed to do it, sometimes if you get it wrong, it could damage the engine physically. Now, people didn't understand why, but if you look at the PAP engine, if you have a build-up of charge clusters, then the charge clusters can cause iron and ferromagnetic materials to fracture because you actually get monopoles building up in the metal. And if you get it in aluminium, it can cause it to change its rigidity. If it goes through a threshold, it becomes a fluid, like the indium did, as I described earlier. It's not melted; it's turned into a jelly-like state. And jelly is not very good when you're trying to do an explosion inside jelly. If you've ever put an explosive in jelly, it's fun, but it isn't like maintained, right? Uh, but the beauty is that the carbon is the antidote. And
Yeah.
it's because carbon itself, nanoclusters of carbon literally form hexagonal rings, and they have a toroidal moment above and below. So they really like to be sucked in when they're in that particular structure. They are similar in their organization. And carbon is in the CNO cycle, it is a catalyst. So if you keep adding protons to carbon, it ends up back at carbon, right? So you can end up with some helium production, but everyone thinks about the CNO cycle, but in these structures, carbon is just a source of alpha particles. It's tri-alpha. So when you go in, if you have like, let's say, if you've got 3 alpha particles and you want to get to 4, you just need to find a balance of 3 going in, and you might produce oxygen because it goes in and all the nuclei reorganize. And so you can synthesize oxygen from carbon. And so, yeah, that's basically probably what's going on in other aspects of the technology. It's just a source of alpha particles, and oxygen is an alpha particle. And also in some of the ball lightning clusters that you see on the North Pole, and you're going to see lots of video on Thor's Day, where the ball lightning hits the metal and it splays out calcium sulfate crystals. And at the end of the calcium sulfate crystals, you have an iron-rich crenellated spheres on each of the branches, right? And so if you could imagine a very large ball lightning has hit with all of this material that it sucked in, and then it's depositing it out. And what is calcium sulfate? Well, it's calcium, which is the highest pure alpha nuclei, right? It's what I call dec alpha, 10 alpha particles. Sulfur. Sulfur is 2 oxygens, and oxygen is quad alpha, right? So it's oct alpha, and then oxygen is quad alpha. So it's quad alpha, oct alpha, dec alpha. It's all comprised of all alpha particles. So that calcium sulfate could have just come from transmuted carbon. And then you have these questions: where did all the calcium sulfate come in gypsum deposits? Where did it come from? Like, why is gypsum where it is? Why can you go and mine gypsum? Well, maybe there was a lot of this process going on in the bowels of the earth, and it comes out and deposits. And this is where you get to the geological LENR processes going on. And I translated a bunch of those from last week's Russian community because there was this excitement about this paper published by 2 Israeli guys on the fact that they think that LENR is the cause of the elemental abundance in the crust. Something which I've been saying for most since 2017.
Yeah.
But I know I'm not the first because, other people have suggested that might be the case to me. But it was actually seeing the experiments and what they're doing and seeing that these are producing all the elements in the crust. It kind of led me to that conclusion. But yeah, it could be producing calcium. And if you're getting calcium, then this isn't 3 alpha particles, it's 10. So you get three calcium nuclei, and you've got 30 carbon particles in there. Is that right? No, I don't know whether it is. Let's try to 10. So that would be 30 to whatever. A whole bunch of carbon particles would end up being calcium sulfate.
Yeah. Okay. Right. So, and experimentally, there has been no indication of long-running generators that have been deteriorating in function.
That, to the best of my knowledge, that is the claim that's made. As I say always, I haven't done that length of test myself, so I can't say.
Because that would, of course, be something that
I think if you combine this expired patent to regulate the amount of moisture that comes into the device. He's already done what I asked him to do, which was bring one sphere to the other, and it makes it more compact and it makes it able to flash, in my view, and do the magic of the Armstrong electrostatic boiler. And this is the same thing that's going on when you do that child's play experiment that I just described. You're flashing that water immediately to steam and so on. So
are both spheres necessary, or can you do with only one of them?
well, his original open source design only had one.
Yeah.
I'm telling you that all you need is charge separated material and magneto-hydrodynamic shear. And specifically, you need to flash to steam as fast as possible. That's, in my view, what you need. I think because a sphere is almost perfect for creating resonant nodes, you will end up with what is, my hypothesis is, you end up with effectively like a Tesla globe. You end up when you can't see the plasma because it's magnetic flux loops. You end up with the yang attached to the inside and the yin attached to the outside, and the gases moves through like a big hedgehog of magnetic vortices. And so you basically have a fuzzball of reaction nodes which the gases are having to move through. And so if they move through, you've got thousands and thousands of tornadoes, and the sphere is the option to produce the maximum number for the volume. There's no other option. And of course, as the gas comes out, it's got hydrodynamic shear this way, and then it's going down that way, so it's got hydrodynamic shear that way. So it's got multi-axis hydrodynamic shear. You're going to get that with a tube, but you're not going to maximize this relationship between the inside and the outside and having all these different structures. And you can see them, you can see where they have the inside, outside of the inside, and where they have the inside of the outside. You can see where, and it produces this regular array of hexagonal or pentagonal carbon deposits, which have an iron-rich crenellated sphere in the center.
Yeah. Okay, so Peter, do we have any other questions? You look a bit tired. Are you overloaded?
This was a lesson learned. That was just sitting and trying to follow up. But again, I think I got the most important thing is for us to give an understanding, because some of the things that we're working on is also assets to get funding to spread this out, and that is also why, if we want to have this one tested and bring money men in, that we need also to use the industry, because this is actually, and there will be some testing of that one, and that's also why that we will say the maritime world, like the shipping industry, where it really can make a huge difference, not only the CO2 but also the CO, et cetera, also sulfur and whatever. But it's if we should actually use this as an accelerator to do something. It was a really interesting one to talk about the carbon monoxide. That was a lesson learned, because I totally agree with you and using the carbon monoxide actually like extra diesel for the engine.
Believe me, Peter, I was trapped for 4 hours in a traffic jam in Hanoi. It was hell on earth.
It is. And that is actually what I'm actually thinking of. Of course, they also see the financial perspective into it and say, where should we start if we should do some testing, so they can also gain some money back, whatever kind of investment they're going to there. Wouldn't that be going, to like a power plant, that be the most simple thing? Or, where do you see for them, if they should start to writing checks for us to do a lot of testing for the next couple of years, where will it be easier for us to go into, besides, going and say that we can also kill, carbon monoxide, so it'll be more healthy to live in Hanoi? What do you see?
obviously the big energy using technologies like producing cement and these kind of things. And there's a lot of cement being used in Vietnam at the moment.
I know because one of my friends, there's a Danish company called FL Cement. They have actually sold most of the cement factories in Vietnam.
Right.
And that's for sure is the CO2 killer of the world, right?
Yes.
Just in Denmark, we have one cement factory that is 25% of the total CO2 in Denmark. That is more than Maersk is giving just of that single cement factory.
Okay, so I'm going to throw something in the mix here, which I think is indicative of the process that's going on, but it's more precise in the way it demonstrates it. There's the leader of the Russian conference, what's his name? Zatelepin. He, working with Shishkin, developed an experiment because they saw some observations and they saw how these clusters are created and so on. So what they have is they have either an arc or a exploding foil, so a pulsed arc or an exploding foil in a hydrogen containing or water moisture containing chamber. And then round the outside, they have a helical glass fiber. And that glass fiber gets fed into a chamber. And in that chamber, they have just CO2. You're going to love this. You're going to love this. They then pass a laser through that glass fiber, and they then do the sparks in the moist air or the exploding foil. At the output of the glass fiber, where the laser is traveling down, and the laser comes out here, underneath on a Petri dish, they collect a white product. And that white product they sent me last year, and I analyzed it. And it has aluminium in it, not in any of the starting material. Now, oxygen is the most abundant element by far in the crust of the Earth. Carbon is something that everyone says, got to deal with it, right? Okay, they only had CO2 in that environment. If you take carbon and oxygen and fuse them, you typically get silicon, but another one is an exchange reaction where you get carbon and oxygen fusing to and fissioning to aluminium plus hydrogen. But if the hydrogen, sorry, if one of those nucleons becomes a oxygen 17 rather than oxygen 16, then you can, well, let me just check that. It's 17, still 29. Now you still get the exchange reaction. And we observed, I observed this aluminium. Now I've published all the presentations on that. And aluminium is the third most abundant element in the Earth's crust. So if we're arguing that this process is what results in what we see in the crust, and of course, carbon and oxygen fused together make silicon, which is the second most abundant element in the Earth's crust, right? So you have 1, 2, and 3 that come out of this process that you see in the Earth's crust. So what you're doing is you're seeing and 2 fused aluminium goes to iron 54. So you're seeing in miniature a literally a kind of like test bed experiment that could be producing the elements that are being produced in the thunderstorm generator and many of these other systems. So we're getting to a point now of, and what it is, they found that these neutral structures, they must be neutral because they come out of the glass chamber into the glass fiber, and they can be carried by photons through the tube. You could even have a device where you have massive spark discharges in a water-filled environment with glass fibers, and these are only 5 milliwatt lasers pointing into a chamber, and it's converting the CO2 directly into metal.
Crazy.
That's where we need to talk to the industry, right?
Have you written the patent?
So we are at the birth of a whole new blue ocean of science.
Yeah,
we are.
For sure.
Have you written the patent application already?
No, it's all published. Sorry.
Okay. Okay.
The thing is, you're going to have most people who don't believe it, so you don't have to worry about them. Then you've got a large proportion of most of the rest of the people that aren't capable of it, and then you're going to have those people that are capable of it and do believe it. They don't understand the minutiae. And I've worked with scientists who can do their experiments all day long, but it took us 2 years to work out what they weren't telling us because they didn't realize it was important. They just did it anyway. So
Yeah.
here's the thing, you're going to be able to get expertise because you're effectively first movers, and you're going to be able to deliver based on that expertise. Whereas other people can make up the fact that they can do it, but they won't be able to do it. And it's what Elon Musk does. He says, like, here's the design for my motors in my cars. Good luck. I'm not going to bother patenting it because I'm going to waste time on that.
Yeah.
The point about this space is because it's so transformational, they won't allow you to have the patent if you try.
No.
So it's better to just be open.
Yeah.
The other beauty about this is my argument with Malcolm. I said, Malcolm, I will not work with you if you're closed. You have to be open.
Yeah.
I said, I see you got something there. I'm willing to try and explain it and so on, but I'm not going to do it if you're going to be closed. And it annoyed a lot of his investors, but we are where we are now, which is, people can understand it better.
But still, he's open on the non-commercial applications, but still he has the patent to protect commercial applications of what he's doing or what.
That is the principle he's working on. Yes.
Yeah. And I think that's a brilliant.
I mean,
way.
even being having a patent, that's actually a part of being open. But the way that he's done it is that the patent is for a particular form and function. And so it's kind of like the round corners on an iPhone. Yeah. You can make a phone, but if there's a better implementation, and that is kind of where he's gone with that. So yeah, I mean, my view is you get so much more back from the international community when you're laying it out there. And because more people can talk about it, you're going to get more people coming and knocking down your door. This will help Malcolm and so on. So, like, I where I can help is where I try to help, is to help support. My view is my role is just to try and help people understand what is possible. Because that's the highest barrier. They go immediately on Google and they find out, or Wikipedia, and they can't find the answers that come from me. And they think it can't be possible because it's not already on Wikipedia, and it's such an absurd argument. And even like I tried on Grok to find out about EVOs, and it's referring to two papers by Dr. Graham Hubler, formerly of the U.S. Naval Labs and of University of Missouri, and they are complete limited hangout disinformation papers.
Okay.
And that's the only ones that get picked up by Grok. So people can't even use AI to find out the truth.
Okay.
We're talking about applications of the primary research, but in all applications, you're going to have to do some work to make it work.
Definitely.
Yeah, exactly.
Definitely.
Yeah. But that's also easier, right?
Yeah.
So thank you very much.
Thanks,
Pleasure.
guys. Take
Thanks,
care.
Dean. Thanks,
Thank you.
Take care.
Bye-bye.
Bye-bye.
Bye-bye.